Photograph a historic site, help Wikipedia, and win a prize. Participate in the world's largest photography competition this month. Learn more. Weibel pallid body. 11 languages. Weibel pallid bodies, WPBs, are the storage granules of endothelial cells, the cells that form the inner lining of the blood vessels and heart. 1. They manufacture, store and release two principal molecules, von Willebrand factor and p-selectin, and thus play a dual role in hemostasis and inflammation. 2. Etymology, edit. Weibel pallid bodies were initially described by the Swiss anatomist Ewald R. Weibel and the Romanian physiologist George Emil Pallid in 1964. 3. Pallid won Nobel Prize in Physiology and Medicine in 1974 for his work on the function of organelles in cells. Constituents, edit. There are two major components stored within Weibel pallid bodies. One is von Willebrand factor, VWF, a multimeric protein that plays a major role in blood coagulation. 4. Storage of long polymers. A VWF gives this specialized lysosomal structure an oblong shape and striated appearance on electron microscope. 5. The other is p-selectin, 6, 7, which plays a central role in the ability of inflamed endothelial cells to recruit passing leukocytes, white blood cells, allowing them to exit the blood vessel, extravasate, and enter the surrounding tissue, where they can migrate to the site of infection or injury. Additional Weibel pallid body components are the chemokines interleukin 8 and eotaxin 3, endothelin 1, angiopoietin 2, osteoproteogerin, the p-selectin cofactor CD63/LAMP3, 8, and 1,3. Fucosyltransferase 6. Production, edit. Multimeric VWF is assembled head-to-head in the Golgi apparatus from tail-to-tail VWF dimers. VWF multimers condense and twist into long, helical, mostly parallel tubules separated by a less dense matrix of protein domains protruding from the tubules. 9. The Golgi then buds off clathrin-coated vesicles which consist almost exclusively of VWF. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. Immature Weibel pallid bodies remain near the nucleus, where they acquire more membrane proteins and then disperse throughout the cytoplasm, carried along microtubules by kinsons. 8. Clathrin-coated vesicles bud from immature Weibel pallid bodies, reducing their volumes, condensing their contents, and removing select membrane proteins. Maturing Weibel pallid bodies may also fuse with each other. 9. The only parallel organelle in physiology is the alpha granule of platelets, which also contains VWF. 10. 11. Weibel pallid bodies are the main source of VWF, while granules probably play a minor role. Secretion, edit. The small subset of Weibel pallid bodies tethered at the cell periphery to the actin cortex serve as a readily releasable pool that's replenished by a larger pool of microtubule-associated bodies in the cell interior. 8. The contents of Weibel pallid bodies are secreted by one of three mechanisms. 9. Some undergo exocytosis individually, while others fuse transiently to the plasma membrane in a lingering kiss that opens a pore large enough for only their smaller cargo, for example IL-8, CD63, to diffuse out. 9. Weibel pallid bodies may also coalesce into larger vesicles called secretory pods for multigranular exocytosis. 9. Secretory pod formation is mediated by interposition of tiny nanovesicles between bodies. As Weibel-Palade bodies fuse with secretory pods, their VWF cargo loses its tubular form for spaghetti-like strings that are then exocytosed through a fusion pore. 9. Whether cargo besides VWF is exocytosed from secretory pods or selectively retained is uncertain. Different modes of cargo release from Weibel-Palade bodies may be a mechanism for differential release of subsets of molecules in different physiological conditions. 9. During secretion, the VWF molecules fuse together into the final concatemer strings. 12. Clinical significance, edit. The importance of Weibel-Palade bodies are highlighted by some human disease mutations. Mutations within VWF are the usual cause of the most common inherited bleeding disorder, von Willebrand disease. VWD has an estimated prevalence in some human populations of up to 1%, and is most often characterized by prolonged and variable mucocutaneous bleeding. Type 3 von Willebrand disease is a severe bleeding disorder, like severe hemophilia type A or B. VWF acts in primary hemostasis to recruit platelets at a site of injury, and is also important in secondary hemostasis, acting as a chaperone for coagulation factor 8, FATE. 13. See also, edit. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. Endothelial activation. References, edit. 1. Standring, S. 2016. Gray's Anatomy, The Anatomical Basis of Clinical Practice, 4th ed. Elsevier Limited. P 132. ISBN 9780702052309. 2. Valentigen Kilometer, Eichenboom J., April 2013. Weibel-Palade bodies, a window to von Willebrand disease. Journal of Thrombosis and Hemostasis. 11, 458192 do. 10.1011/JTH.12160. PMID 233988618. 3. Weibel E2, GE, October 1964. New cytoplasmic components in arterial endothelia. The Journal of Cell Biology. 23, 110112 do. 10.1083/JCB.23.1.101. PMC 2106503. PMID 142288505. 4. Wagner DD, Olmsted JB, Marder VJ, October 1982. Immunolocalization of von Willebrand protein in Weibel-Palade bodies of human endothelial cells. The Journal of Cell Biology. 95, 135560. do. 10.1083/JCB.95.1.355. PMC 2112360. PMID 6754744. 5. Tumor RF, Duran WN, Lake eds. 2008. Microcirculation, 2nd ed. Amsterdam. Elsevier/Academic Press. pp. 38. ISBN 978-0-12-374530-9. 6. Bonfanti R., Fiore BC, Fiore B., Wagner DD, April 1989. PACHM, GMP 140, is a component of Weibel pallid bodies of human endothelial cells, PDF. Blood. 73, 5 1109 12. Do. 10.1100.v73.5.1109.1109. PMID 2467701. 7 McEver RP, Beckstead JH, Moore KL, Marshall Carlson L, Bainton DF, July 1989. GMP 140, A. Platelet alpha granule membrane protein, is also synthesized by vascular endothelial cells and is localized in Weibel pallid bodies. The Journal of Clinical Investigation. 84, 192-9. Do. 10.1172/JCI114175. PMC 303,957. PMID 2472431. 8 ABC Doyle L, Raja V, Ferrero F, Termain M, Saftig P, Cutler DF, October 2011. CD63 is an essential cofactor to leukocyte recruitment by endothelial P-selectin. Blood. 118, 15 4265 73. Do. 10.1182/blood 2010-11-321489. PMID 218038446. 9 ABCDEFG Valentigem kilometer, Sadler J.E., Valentigem J.A., Voorburg J., Eikenboom J., May 2011. Functional architecture of Weibel pallid bodies. Blood. 117, 19 5033 43 do. 10.1182/blood 2010-09. 267,492. PMC 3109530. PMID 212666719. 10 Blair, Price, Flomenhoft, Robert, the 17th of July 2009. Platelet alpha granules, Basic Biology and Clinical Correlates. Blood Reviews. 23, 4177189 do. 10.1016/J.BLRE.2009.04.001. ISSN 0268-960X. PMC 2720568. PMID 194509111. 11 Carnegie, S. Faz, S.A., She, Q. Haberichter, S.L., Montgomery, R. August 2012. Contribution of platelet versus endothelial VWF to platelet adhesion and hemostasis. Journal of Thrombosis and Hemostasis. 10, 8 1646 1652 do. 10.1140/J.1538-7,836.2012.04797.X. PMC 3419786. PMID 2264238. 12 Lenting P.J., Christophe D., Dennis C.V., the 26th of March 2015. Von Willebrand factor biosynthesis, secretion, and clearance, connecting the far ends. Blood. 125, 13 2019 28 do. 10.1182/blood 2014-06-528406. PMID 257129991. S2 SID 27785232. 13-carat Valentige kilometer, Iken Boom J, April 2013. Weibel Palade bodies, a window to von Willebrand. Disease. J. Thromhemost. 11, 458192 do, 10.1111/JTH.12160. PMID 233988618. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. External links, edit. Weibel Palade bodies at the U.S. National Library of Medicine. Medical subject headings. Mesh. Category, organelles. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF.